Hey guys, Mr. Middleton here. Today we're going to deal with the polygon angle sum theorem. At the end of this video, you should be able to use the two polygon angle sum theorems to find missing angle measures. Excuse me. And you should be able to differentiate between convex and concave polygons. Alright, let's start with the definition. A polygon is a closed figure. Polygon is a closed figure with at least three sides that are segments. The sides only intersect at their vertices. Or at their vertexes. Vertices. I'm sure. I hope it's spelled that way. Alright, vertices. Alright, so now looking at these four figures, which ones are polygons? And we're going to stick with the definition here so that will help us out. So this first one's a circle. It doesn't have three sides. The sides definitely aren't segments. So this is not a polygon. Let's shift that up now that we're done with that part. Okay. 1, 2, 3, 4, 5, 6 sides. This is a hexagon. All of its sides are segments. They only meet at the vertexes. Works out. 1, 2, 3, 4. This looks like a quadrilateral. 4 sides. All meet at just the vertex. Works out. This is not a polygon because the sides meet at a place that is not a vertex. Okay, so not a polygon. Okay, there are two types of polygons. Convex polygons we'll deal with mostly, a lot more than concave polygons, but convex polygons are polygons with no diagonals with points outside of the polygon. Okay, and so if we draw the diagonals, all that means is we're going to go from one vertex to the other vertexes that are not on the same side or don't share side with the vertex. So I won't draw one here because that won't be a diagonal, but I'll draw one from here to this edge. That's one. From here to this edge, that's two. Okay, so it's a pentagon. See that it has two diagonals. Okay. Alright. Concave polygons are polygons with at least one diagonal with points outside the polygon. Alright, so we can go anywhere really and see this. I'll start from here. Okay, if I start drawing my diagonals, this one works, doesn't go out. But then from here to here, straight line, see how that diagonal reaches outside of the figure. I guess you could draw a bunch of them because there are a bunch of different sides here. Okay, but you notice that it only took one space outside of the polygon for us to realize that this is a concave polygon. Okay, if you wanted to do it again, drawing the diagonals, let's see, diagonal here, diagonal here. I guess we could continue that for the next one. Okay, go outside the polygon there. Alright, and so I like to think of that concave, I think of caved in. That's the word that I think. Okay, there's a cave, divot inside, and that shows that it is not a convex polygon. Okay, alright. So you have an enrichment sheet that goes along with this worksheet. Enrichment 3-4. Alright, pause the video now and come back and see the answers to this. Alright, so I gave you plenty of time to pause it and complete that worksheet. Okay, hopefully you got it. You understand what's happening. And if so, you should be able to answer each of these questions. So try it out. Do that. Alright. So now that you gave that a shot, hopefully you gave it a shot. If you haven't paused it, give it a shot. We're going to try to find the total degree measure of a 64gon. Alright, if you see, and you completed that chart to the end, you'll see that there's a pattern that happens with solving for how many degrees a polygon should have, a convex polygon should have. And so that formula should have been n minus 2 times 180, n being the number of sides. So for a 64gon, just a polygon with 64 sides, it'd be 180 times 62. And that gives us 11,160 degrees. Alright? Okay? And I kind of spilled the beans up here. But what is the total degree measure of any n-gon? Okay? That is this formula. This is the polygon angle sum theorem. Okay, is that we can find the sum of any polygon, any convex polygon angles by saying 180 times the number of sides minus 2. Alright, flip them to the back. Alright, back side of the enrichment sheet. Try this out. Try this out. Alright, so if you did the back side, then you should be able to answer these questions. What is the measure of all exterior angles of a 26gon? Okay. The total measure of all exterior angles of a 26gon will be 360. Okay. What is the total measure of all exterior angles of any n-gon? Remember n being the number of sides. Okay, and that answer is 360. The sum of all exterior angles for any polygon, or a convex polygon, is going to be 360 degrees. Okay, that will not change. That is a constant. All right, another vocabulary word we'll learn and use is a regular polygon. Now, a regular polygon does not mean normal. Regular polygon is one that is both equilateral, equal sides, and equiangular. Means all the sides and all the angles are the same. They have the same measure. Okay, so let's find the measure of each angle in a regular 15gon. All right, and this is how we're going to do this. First, we need to know how many degrees are in a 15gon. And we can find that just by using our polygon angle sum theorem. 180 times 15 minus 2. 15 for the number of sides. And that gives us 180 times 13, 2,340. Now that's the total degrees in a 15gon. But we want to find, this question says the measure of each angle. And so that means that we don't want to know the total, we want to know what every single one is. And we know that because it's going to be regular, that all of them are going to be the same. So now I say I have this many degrees spread across 15 angles. So in this case, I'm going to divide this number by 15. Oops, not 150, 15. And that means I know that each angle is 156 degrees. And I can do that pretty easily in general. If I want to find the measure of each angle in a regular polygon, I'd do 180 times n minus 2 divided by n. Okay, in this case we used 15 sides, but we could do n for any case. Alright, next example says find the measure of each exterior angle in a regular 18gon. Okay, what do we know about the sum of exterior angles? They all will be 360. Will all be 360. Okay, a regular, remember, important word, guys. Regular means that all the angles are going to be the same. So there are 18 angles. 18 sides means there are going to be 18 angles. I can find this by saying, okay, 360 divided by 18. Pretty sure that's 20, but I'm not that sure. 360 divided by 18, 20. Okay, so I know that the measure of each exterior, that means every one, is going to be 20 degrees. And again, we can find this generally by saying, okay, exterior angles is going to be 360 divided by the number of sides. Okay. Alright, so that's the polygon angle sum theorem. That's us being able to distinguish between convex and concave polygons, and we'll be able to find the sum and the measure of each exterior and interior angle in polygons. See ya.